Esto, pero ¿de qué sirve?
Sí. Bueno, es un eso que los niños más.
Pero que es para principiantes. Como en Matrix.
Exacto, exacto. Sí,
Que saltan.
Le vendrá bien como para empezar.
Ya las panchitas no acaba de instalarse.
Bueno, eso sí.
Sospita que no tinc de pensar i creat un emblema. Doncs torno a calidar aquí. Si jo faig un projecte amb unes llibreries aquí i unes websites, jo per importar-lo només faig link freeze i al nou ordinador li dic, vale, quan creïs l'environment, utilitza tot el software bit freeze.
Ya después te vas a...
¿Y ahora qué ha cambiado?
Aquí puedes
Escribir el código de... Para no crear red,
Tengo que saber menos.
¿De Mac?
Vale, eso por eso. Esto es para debuguear. Entonces, ¿qué es lo que nos permite?
Mira, Antonio,
Aquí es como corre el código, pero
luego està entre un dels mails que hi ha amagat.
se va a cambiar. Per exemple, ara
No, puedes poner
Sí,
sí, igual que manda.
acá y te puedes ir a la consola de bueno, que es y aquí puedes manipular igual que en
Vale, vale. Pero, sí, vale, es menos eficiente, pero para aprender es mejor.
para aprender y para debuguear. Después.
Python, la que llevas una semana probando en Python, no tienes que desbloquear cosas con tema.
¿Y cómo se limpia esto? ¿Esto qué es?
Aparte,
La línea de esa.
bueno, creo que también. Y terminas un código, o sea, por si tuvieras un código de muchas líneas, es como una forma de deslizar más rápido.
Ah, vale, es una miniatura.
Es un y bueno, por ejemplo, para sumar, no es tan sencillo como voy a hacer como
Siendo bastante estúpido, pero bueno. Una primera.
Python se miran dos.
a ver, yo, lo que quieres es aprender, no te recomiendo tratar de entender.
Pero, yo de Kratos.
Aquí son los solvers académicos, son los que utilizan.
CIMNE va tirar, sí.
Son los que más
No se va tirando.
Ja estic, la verda.
los solvers industriales que son
Ara que repetir, no? Filtra Fritir.
pues Kratos es una cosa intermedia donde
Vaya en Fritir, no sé si podré grabar.
es poco probable que las Kratos, creo que se serio las Kratos que tú le vas a meter
Yo siempre he trabajado antes. Yo, para hacer algo que no está nosotros O sea, la idea es, yo ahora he empezado y ya estoy haciendo cosas, pero solo busco datos desde aquí. La idea es que cuando esté avanzado y un poco que por esa actividad queremos ver
Recording in progress.
a revisar todas las cosas
Hay que iniciar vídeo para que
siempre vas a tener que pasar
Sí, no, a ver.
la documentación de Kratos y la documentación de Kratos.
Vale, aquí.
Que cada cosa de la
Presentarme.
¿Cómo lo abro? El código modelo. Yo quiero editar. No, yo quiero editar un modelo. Hablo del MDCA.
sacar ideas para eso ya está.
Ya domani.
Sí, porque o sea, lo puedes hacer los apuntes y yo puedo estar en JSON.
Todo llegará.
O sea, referís a eso cuando
Aparte de eso, lo que puedes hacer es, yo que sé, imagínate que quieres aplicar una condición que no está escrita en un solo eso sobre todos los nodos de cada nodo que está aplicando esta función de aquí. Si eso no estuviera, lo tendrías que probar tú en Python seguramente.
Tienes ahora la pantalla de
ya lo estoy conversando, pero
Están dos niveles. Usuario,
claro, no. Sí, pero la idea es que yo aquí por Python en pantalla
perquè comencem. Suposo que la gent ja va.
pero espera, interesante.
Aquí no és perquè només ho vegin aquí. Okay, let's try to do the practical part. I introduce you Antonio Garde. He is working on this also with me in my learning, and I prepared some practical exercises. So the first thing we want to know is who of you have a code before in Python? Can you please raise your hand? Okay.
Almost everybody.
Who doesn't? Okay. And now, can you raise your hand? The ones that have never used Python before. Okay. Okay. So let's try to be in couples of people who know and who haven't. So again, the ones that have not used it before. Okay, so you can go with, have you used this before, the Python?
A little.
And you? You?
Okay,
could you change with him and you help her and you help him in Python? Who else? You're okay? Who else have never? You will also. Who else have never done Python before? You have used it or not? Python.
You know how to
And there, you were saying, you know Python?
Ahí,
Okay.
I'm Python Pro.
No hem de parlar pels que estan online.
So there's a problem, or like just installing the thing? You probably have to install yeah, that's cool. You already have it.
Okay, let's start. So Antonio, when you want, please.
Okay, so good afternoon to everybody. My name is Antonio Darder. I recently finished my bachelor's degree with Alex, who was my director of my thesis. And I developed my thesis about numerical tools and machine learning. So yeah, I did my thesis in developing code about neural networks and all that kind of stuff that hopefully we will do it here as well. So the idea is to code the programs from scratch. So we won't be using libraries to minimize the functions, and we'll use some, but the basic ones. So the idea will be that we code all from the beginning, and some small examples about the things that we did in that Alex explained.
Ese pasaje mío salió del proyecto
today we will do linear regression.
cuando yo había llegado.
polynomial regression. That's what Alex explained in the class before. And then we will try to implement regularization as well to prevent overfitting and underfitting. That's the last thing he explained. And finally, we will try to see that last thing that Alex was explaining, to how to choose the best rate, the capacity of the polynomial, like to choose degree 10, degree 3, and the lambda as well. And we will try to see that. So the knowledge in Python is really not that necessary, but it's better if you use it with another person that is more used to, so it will be faster. So I think they uploaded a file that you can download, which is a folder that contains the things that we will use during this session. And how I will do it is I will share my screen. It's a Google Colab. I don't know if you have worked with Collaboratory before, but it's just a tool that from Google Drive that you can code in Python and run it in that space. So we will do it like that. I will share my screen and we will be coding, and yeah, that's how it will work. So if you have any questions during the explanation or anything, don't hesitate to ask, because I will be on my own. So we can start with the session if you are all okay.
I think that it's not updated.
No?
No, it's okay. Meanwhile, you can explain the PDF.
Okay.
They told me they are.
So about the contents, as I said, we will be always doing some code from the things that I'll explain in the morning. So for today, we will do linear regression. Tomorrow, we will pass to classification. Let's remember some of the equations that I explained this morning. So everybody should be seeing my screen that I just shared. And yeah, we'll start with linear regression. Okay, so we can quick refresh about the equations. We are trying to predict some data X that we have, a matrix. As Alex said, we have in the rows all the points, and in the columns we'll have the features, using a set of parameters theta. So like this, we want to estimate some values, and we usually call that y hat. These are the cost functions that the L norms that Alex said. This is the L2 norm, the difference of the squared values. This is the L1 norm, absolute difference, and the L infinite norm, which is just the maximum of the differences. So for the optimizations problems, we know that the solution for the L2 regression is analytically solvable, it's direct, and it's just this equation. It's X transpose X, take the inverse, which is sometimes a little bit expensive, and X transpose Y. So, and for the L1 norm and L infinite norms, we said that we could rewrite the optimization problems, adding another variable t, which are the bounds, and we can rewrite this in a canonical form, like this. Alex showed in the morning as well. So for the solution of the L1 and L infinite norms, we will use a linear programming library, which is really basic. It does the interior method that Alex said, interior point method, and it asks for these bounds and for these matrices, and it gives you the output, the optimum parameters. Then we move to L2 regularization, which was introducing the term lambda and theta transpose theta, which is theta squared. Well, and the solution using L2 norm, it was just to add lambda identity to the equation. So in which matrix X are we going to use? we're going to use a famous data set, which is the Anscombe quartet. There are 4 data sets with 11 points that it's famous, it's a quartet, because all of them attain the same regression line. Although they are different looking, for example, these are 2 of them. They are pretty different, but the L2 regression obtains the same line for both. So the same parameters theta. And we will use from this quartet just these 2. Here we will fit a regression and see how it looks. And this one will be really interesting because it's, as you can see, it's a straight line, but it has a massive outlier. And as Alex said, the L1, we will see how the L1 norm doesn't care about this outlier and will fit a nice line here, whereas the L infinite norm will look different, you will see. So we can start the coding part. It's a block there.
I don't see it.
Okay, so I continue explaining, and when we have the code, we will start. So, as I said, we won't use many libraries, just the basic ones. These 4 CSV is will be just so that we can load data in CSV format. The datasets will be in CSV. NumPy, it's the basic. I'm pretty sure all of you are familiar with it. It's the basic library that supports matrix and vector operations. And from matplotlib, we will import pyplot, which is for the plots, and from SciPy optimize, the linear programming, that it's the function that will solve L1 and L infinite norms. So because we don't need the collab really. We don't program it from the beginning, but we need the data sets, so we can actually fit something. So just a moment. I hope they upload it.
Estàs pel xat si el tens.
Puc passar arxius pel xat?
I never worked with Python, but I'm for removing with that.
We will put the documents in the chat. They will be uploaded also. I don't know. Are they already uploaded? If not, I will.
No, they're not recording.
Yeah. New file. I feel bad that I thought the Python directly worked as being my
Yes,
With the purchases. Then you can
Estic compressat. És la meva predicció. Està instal·lat un moment. Però si ho fem des del col·lapse.
Okay, so I think you have the files in the chat.
Okay. Maybe we are not connected to the session.
Yeah.
I think they told me that they are going to upload it in 2-5 minutes. But just for the ones that are connected, you can already take it.
Maybe can be accessed online without.
The link. Yeah.
But
I don't know if they are public or.
Probably.
But we will have to be in the meeting as well to know the link.
Jo faré dins de la carpeta de FAMS o alguna cosa així, vale? Sí.
Quina contrasenya has utilitzat?
No sé, m'ha sortit una per defecte i he dit una que sí, que ja tenia posada. No,
No, sí, s'ha quedat.
Someone else has
No, perquè no puc ir.
Ja està penjat,
Ja està penjat?
They are already
Because si entren després.
They are uploaded to the...
Okay. They uploaded already the files. You can download it now.
Yeah, now you can download it from.
Here we have the
Sí, obre. No, que ja sé la
We work with...
Okay, so you already have it, I think.
Yeah, everybody can.
Okay, so the first we have to do is to upload the files, the data files to the collab session. So we go to this folder and this icon here, and you can just, wherever you download it, you can select both of the three of them and open. It will appear here that you have already uploaded. Okay, so Colab works in a way that you build cells, different cells, and you can run each of them separately. So we'll have to be running each cell separately. So the first cell, which was the imports, we can just run it. And it says, okay, it doesn't have any compilation error. Then you will see that you have this code here, which is a code that we give you to manage the data, because the data is an important part of machine learning and sometimes gets a little bit tedious to manage it. So we created this code that has some methods, and we'll make the CSV files into the matrices that we are going to use. So we run it as well. And when we have run it, we can initialize our data. So to do so, we just call the class data and the name of the file.
Who has already uploaded the files? Who has the files uploaded in the Google Colab? People are still uploading it. You should open your drive. Upload the files to the drive. Explain it again, maybe, Tony.
Okay, so yes, sorry. You downloaded a file that is ipynb.ipynb. That's the Colab file. So you have to go to your drive, or you type Google Drive or Google Collaboratory, and you have to open Google Collaboratory, and then I can do it.
I had to install it because I never use it. Maybe,
yeah.
Maybe some other people. Yeah, but it wasn't installed in my drive. Maybe somebody doesn't know.
Okay. Okay.
It was easy, but yeah.
I didn't know that it has to be installed.
You PC as the policy, and then you have to upload it. I don't know what was here.
From Google Drive, pero ¿por qué no?
I think that it's this one. The other one is the solid one.
Drive account. Yes, I could
Yeah, because last year he directed and told us to release yes. And then you can either create an empty node doc from scratch, or you could just open the one.
No, no, creo que te lo han puesto bien. No sé, ¿por qué?
Load the data file. Sí, no link. Sí, okay.
You don't need change. You can do
Graph icon allow you to connect it from.
you run on open single loop project.
Yeah, we will be running and adding some lines. Okay. Okay, so the files, I put them in the chat, so you download them, and the one that's the .ipynb, this one will have this one here, one linear regression.ipynb. You have to upload this into a Google Collaboratory, which is an online tool from Google Drive. So you open Google Drive, then you open Google. This is Google Collaboratory, and here you do archivo and upload notebook, and you select file, and you select it, and it will upload it. Okay, so you already have this in, I think some of you have in Jupyter, is also okay. You can use Jupyter Notebook. It's similar to Google Collaboratory. And you have here, I have to upload them again, but you have to, as I said, click this icon and upload the .csv files.
Okay, can be uploaded.
And they should appear here.
So, who has all the files uploaded, the 4 files? Can you raise your hand, please? Okay, the ones that they have not.
Yes, they're on.
Okay. Sí, ahora voy the folder seems
Yeah.
Me han enseñado otras cosas.
check oriented. Please open the file and with the CFV with the import data, execute.
I
don't know, but you don't have Google Drive.
Que no sé si
Okay, so maybe you can.
ninguna preferencia.
Yo también.
¿Cómo se escribe?
Que ya no recuerdo qué tengo.
You should have
A way to structure that in the basic instance Excel, what does is
Yeah, now you
So, does anyone has problems with this? There is a one microphone opening now. Okay. Everyone? The microphone.
Okay. So now everybody has the data uploaded, and we can start with the code. So first of all, run this cell. It's the library. It appears green check on the left, saying that it doesn't have any compilation error. And then we can run also the second cell, which is, I explained it before, but it was a little bit messy. So it's, we prepared some of this code so that we can manage the data easier, because the data is really important for machine learning, but sometimes it's a little bit tedious, like to open a CSV file, create matrix and all that stuff. So this class just does all of that for us. It has some methods that we want to explain, and we run it as well. And here we can, I will show how we can use that class. So we create a variable and the name data, and we pass the name of the file. So Anscom B, quartet, data1, CSV. And we can do the same for the second one, which are the ones that we are going to use at the beginning anyways. The quartet, data3, CSV. And this should run okay if we write the name right. And to see the data, we just have to call the method of the plot data. If we write this, both data1 and data3.
Data2. You give it the data2 name.
Thank you. Sí, está en caja.
Ahí está. A ver qué hace.
It's showing one plot.
Yeah, we have to show the plot. So PLT shows.
Typical matplotlib.
Typical matplotlib. PLT show, and it will show two plots. Okay, so these are the two plots of the data that we said before. Also, if we want to plot it side by side, that's also possible. We just tell we want a subplot. This will be and this is the same. This means we want one row, two columns, and this is the first plot, and this will be the second. So instead of up down, it will be plotted side by side. Okay.
Now you add the objects that are called data one. Data like
Is it okay now from the last row? The size? Okay.
Okay, so you should be seeing the two data sets.
How many of you see the data sets now? Could you raise your hand?
Okay.
Some minutes.
You have to call the submethod. No, the method is plot data. You are calling with the dot. You are calling a method or an attribute from that object.
I know.
The method of data is plot data. First, write it down without this. Right? No. You have to write the 1, 2, the number here is like.
Okay, so we have the objects data 1 and data 2, and if we write data 1 dot, it will automatically tell us which methods it has and which variables. So it's got the matrix X, so we can print it. So we will see print data 1x, and we see the matrix. They are 11 points, as we said, and they got X and Y. We could do the same for the data 2 and 1. The same, okay. So if you all have if you all are seeing these plots, we can move to machine learning actually. So first of all, we are going to solve we're going to program the analytical solution of the L2 norm. Okay, so here we have we define an equation function which just returns the optimum theta. So here you should write the equation that solves theta analytically, which is the one that we solve here. We should write this equation, which is the solution for the optimum parameters for the L2 regression. So we can write that. Okay. So if you want to try to write this function, okay, you have 1 or 2 minutes to write it. The equation, yeah. So it's this equation. Yeah.
This kind of object. And y is a vector. And what is x?
And if you want to do it side by side,
That's right. Well, the input is x. In this case, because it's x.
Okay, so for those who don't remember, in Python with NumPy, when you're multiplying matrices, you have to put the arroba function. So this means that we are multiplying two matrices. If you instead of this symbol, if you put the normal product, this will do a dot product, element-wise product. So here in this equation, we want the matrix multiplications for all of them. So this matrix multiplication, and matrix multiplication.
Like this. And to do the inverse and the suppose we have to call numpy's methods.
Yes. So x and y are already matrices. So NumPy matrices. So to call a transpose, you just have to say dot t. X dot t is the transpose. And to call the inverse, I will just write the whole equation. So it will be x times x transposed times x. And we want to take the inverse, so we have to call a function from NumPy, which will be by linear inverse. Okay. And this has to be times x transpose times y. So this would return theta. This would be the solution, but as it is written, it would return a row vector. So as we define theta as a column vector, we can just transpose everything. Okay. All of you have written the equation. Who has already who has written this equation?
You are. I did not even.
Okay, so we can run it to see if there is any compilation error, or it shouldn't be. And then we have to define this other function, which is called build model, because what we will do is, as we saw here, we have a matrix with x and y, but we have to separate this matrix into two matrices, into the x matrix and the y matrix. So x data is this given matrix, and d is the polynomial degree that we are going to use to fit the model. So what we were talking before, the capacity. The equal 1 would mean linear equation, the equal to a parabola, and so on. So this function should have as input the matrix x, and it should return y, which is just this column, and x, which is this column, but it will also have more columns equal to the depending on the introduced. There will be x1, x1 squared, x1 cubed, x1 to the 4th power, and so on. And also remember that the first column is all ones, just the value 1, because that's for the free term of the equation. Okay, because we have the equation x times theta, but sometimes you can see in with x times theta plus theta 0. So it's just compacted. So the first column of x is ones. So we have that extra theta 0. So we have to complete this. I will do it with you. Just so we are a little bit faster. And it has also we can also initialize theta's vector of zeros. So we just say numpy zeros, which creates a matrix of zeros, and we have to give the dimensions, which will be d plus 1, because it will be, this one means it will be a vector, and it will have d plus 1 terms, because to the polynomial d, and that plus 1 is, as I said, the free term, the equation. Then y is, as we said, is this second column. Second one, yes. So we will just use indexing, so we want all the points in the first direction and the second column, which is a1 because it's programming and it starts counting from 0. This will be y, and actually to build x, we will do a loop. So we compute each column to the power of d. So we compute for loop, and then we say that the column y in x will be the first column of x data to the power of I. So first I will be 0, so the first column will be ones, and then we'll take the value 1, which will be x, 2, x to the power of 2, and so on. And here it says that we have to initialize x, so we can initialize it at a matrix of zeros as well. With sizes the same size as x data, row dimension, and d plus 1. It needs to have the same number of columns as theta's there are, because we have to multiply these two matrices. So we run this and it should have the check. So anyone has any question or this? Have you been able to write it?
So who has finished this part of build model is working? Build model is working.
La forma.
So again, build model is working. Could you raise your hand, please?
La primera columna.
Anybody needs help?
Porque te va a regresar, si es una matriz de 2×3, cuando veis.
Okay, so next.
No de la primera columna. Por ejemplo, si tienes una matriz de 2×3, entonces te va a dar un arreglo que es 2×3.
So then we have two functions which are already written. They do just is plots the solution, so it will be faster. We don't have to write this every time. We just take some points and please show the section again. Yeah. This one, build model, no? Sí. Yeah, this one, right? Okay. So if you got it, we run this, as I was saying, we run these two functions that will just plot the solution, and this will compute just the mean squared error, so that we can see the mean squared error. And then this is a small script using the functions that we just defined. that will solve the analytic two regression. So we define the polynomial degree. We say 1, so we have straight line. We open a plot. We use the function build model to create the matrices X and Y. We call them training because they are the ones that we use to minimize the model. And then we call the function analytic L2. So we obtain the optimum parameters. And now we just plot the data, and on top of the data, we can plot the solution calling these parameters. And this is for the first data set, because here we call build model with data 1, and this is with the other data set. So if we just run it, we will see the regression. Yes? Everybody everything clear?
So who has this working, this part working? Okay, who is not working?
No, it's double.
The ones that are not working that we will pass to see.
You need help, or it's just because you are still typing some things?
Okay. In Python, the test should be spaced like the things that are inside 40. You don't have terminate like I don't know how to say sequence. Yeah. So when you write 0 or you do something like that, but in Python it's on like spaces. Therefore, you should want to. Not knowing Python. For that question, because Python. Other things I cannot help you. You run all the ones below, all the three, but in order, the last one we call the one. These are both okay. That was okay. The right, run the one below. Now the last one with the flow. I don't like it, not very much. Go down. I think that you will have the same problem. Go down. Here you have what happened. Yeah, you have the same problem as me. That you see that this is not having problems and this is having problems. It's because here you have the double. Yeah, the double bracket on the other one. I didn't know.
Una pestaña. Cancela del error. Pues el primo.
You can see below where it's. No. That wasn't okay. The other one was wrong. Like this method, I don't know why it's asking you for double bracket. You see the problem is here. Well, there's calling you that is inside the and then it goes. Here it says this line. The problem is that the one, the 7-1. And it's that you need another bracket.
Data.
Like
Here are the input values.
you need another bracket.
All the values are translated.
I don't know why. No, but check. Correct. No, don't correct. This is well, right. Then
Go on. Store y. These are the values you want.
No. The last one? No, the one.
You build our matrix. Let's look at our matrix.
No sé por qué quizá bueno, vamos a solucionar la situación. Pero ya está.
Matrix is like this.
Okay. You want to use this? Yeah. I will show you how to.
Salvarmi un previso, però si cambiava la cosa, perché non si capisce solamente una colonna di
Like the first column is one.
però si
The second column is x Just the like 10
I didn't see the whole code. Catch up.
Sí, sí, dale, dale.
This one is zero. Miradme un fail, ¿vale?
Appears an error.
Okay, one thing, what we are doing is, you see, we're doing xi, so 1 times theta plus xi times theta 1 x, so theta 2, I think. So here we only have one design variable, one x and one y. So y is like this, and x is like this. Two vectors. But then what we are doing is the big X, we are doing ones here, a column of ones, a column of X, and then a column of X squared, X up to 3, something like this. Yes. Okay. So this is what we are doing is this matrix like this and adding more columns here. So what does it mean? It means that x times theta will be, this matrix is x and theta is here. Theta 0 will multiply once, x will multiply theta 1, theta 2 x squared. So we are saying that our bases are ones, linear, quadratic, cubic. So this is our features now. That's what we are doing. Okay. But the first example is with b equal to 1.
Exactly.
So I'll check. Some of you have problems with this function. So the ones that have problems, try to copy it exactly.
The double brackets are important. I had a shilling pretty clear with some settings like right.
Okay, so yeah, as I said, you had a problem is probably in this function or this one that we write. So you can take a picture and write it and copy it because we have to keep moving. So next, we are going to solve this second one, which is of special interest for the L1 norm and L infinite. So we are going to solve them with a linear programming function that gives SciPy. So as we said before, we have to define these matrices. So we can input these matrices to the function of linear programming, and it will return the optimum parameters. So we have to write a function that does exactly that. It returns this C is this vector of which means of the variables. This means left hand side of the inequations, and this is the right side of the inequations. So we can build. We have to build these matrices from here. So here I already done the L1, so you can see how I did it, and you will have some time to try to do the L infinite, which is really similar, but you can change here some functions. And so C, I will explain this real quickly. So C has to be zeros for the thetas, this is theta, and ones for the t variable, which is the same size as theta. So we can do it separately, Cx and Ct, zeros and ones, with the same shape as Cx as columns and Ct as equations we have, so rows. We concatenate these two, so we have just one big vector, and then we have created this one. So now we have to create the left part of the equation and the right part of the equation. So for the left part, we can just concatenate again, use the function concatenate to put A and identity. And we can do it in two parts. So first we will concatenate the matrix A with the identity. We will do as well the bottom part, A with identity. So then we can combine both and do the full matrix. So we build an auxiliary variable to concatenate these two. Another auxiliary variable, we do the same. And then the left part of the equation will be the concatenation of both. And the right side is just B and B. So we just concatenate B and minus B. So for the L infinite, we have to do this same process, but now these matrices here have a column of ones instead of an identity matrix. And here it's just one value, it's a scalar, it's not a vector of ones. So you have a few minutes to do that, but just use this as inspiration, use the same functions and build the L infinite, a function that returns these variables.
Regresar a función.
Es tal porque necesitas cero.
Depende, si tú le pasas este valor y modificas, por ejemplo, dices como x es igual a g, no necesitas darle retorno. Pero si es una variable que tú te inventaste aquí, como es el caso, como se inventó C, o sea, C no viene como parámetro, y entonces tú lo que quieres pasar de como regreso funciones el valor C, que no existía.
Los AUX, como no los quiero, no hace falta que los...
Sí, los AUX son, a ver, o sea, son variables auxiliares y después podrías, más una vez que los dejas de utilizar, lo podrías eliminar durante la función también, si quisieras. O sea, si fuera algo que te consumiera memoria, una vez que ya hiciste lo que tenías que hacer, lo puedes.
It's a one function or it's only a one? It's a one function or it's only a one?
It's only one. If no, but for the column.
Then it's a one matrix.
Exactly.
That's a function with one as for zero. Que hi ha una funció que és igual que la zero, però només has de canviar. Ah, ja ho has fet. Sí. Jo m'he perdut.
Amb la teoria.
Ones is
No feia servir perquè volia.
No, jo paro.
Sí, millor. Clar, perquè aquí diuen que això ha de ser una escala. El problema és teòric, no és pràctic.
Es teórico, lo mío de Alex hasta todavía millón.
Okay, we make it in English now.
Okay.
So You said that we should change this number to a matrix of one with an identity. And the other thing was something about the scala.
Yes, that here zeros is a vector of zeros, and ones is also a vector of ones because we have bounds. For the L1 norm solution, we have one bound per equation. And in the L infinite solution, we just have one bound because we are only taking care about the maximum. So it's just one bound. So this it's just one. Yes.
No, for complete your bounds.
La condició que afegeixes de frontera.
Con el 1, perdón. Okay. In the other case, we only have one.
Exactly. Because in the L1, we are adding one bound. In the L1, we take care about all the points, but in the L infinite, we just take the maximum value. So it's just one.
Això aquí és la dimensió, columna X i 1, això és la dimensió.
Sí, això té que
Llavors, això ara no m'ha ja, però ara s'ha de dir, o sigui, si abans és aquí, aquí no el tenies.
Exactly, it should be exactly one.
A vector that adds one column. So
But then how you multiply one?
yes, because X has the same size as A has rows. So you use that one more.
Unidades hay que poner,
Because it's called you don't I read it on the board.
X es la tesis igual.
No, you have to. You have to.
Minus A. C, right? So to do multiplication, you need the same here and here. So X is a vector that has the same size as A. Okay. Okay. So T is here we just have one T, but this is a column vector. A column vector that matches these columns, but this is just adding one more row. We have one more column. Sorry. We have one column here, all these columns, which is equal to this, and one with one. See? Okay, so okay, so the solution for the L infinite, you can just copy all this and just change the shapes. So CT now is just 1. Okay, and now here instead of identity, we'll have a vector of ones. Ones, and we have to specify the size for the vector, and vector. Change should be okay. We can run it to see if there's any compilation issue. We just changed here the CT from shape equal to A to just 1, and here we change the identity to a vector of ones. Okay.
Okay, who has this definition working? L infinity. Can you raise please the hand?
We haven't tried it yet, but it should work.
You have to the returns below.
What? Ah, yeah, because I copy pasted.
Yeah.
Okay. Now, I said compilation error. I don't know why. So now, like we solved the L2 regression, we will do the same. So we say that we want a polynomial degree of 1, so we have 9, and we call the same functions like before, which are the build model, and we will use the data too, as I said before, to see the influence of the outlier. And now we can call the function that we just defined, which returns C, the left part of the equation, and the right part of the equation. And the function was called L1 limprop. Each data. Yes. So this creates the matrices that we needed, and to find the solution, we just call solution the limprop function that we imported from SciPy, and it asks for C, A, U, B. I don't know why they use this notation, but it's the left part of the equation, and B, U, B is the right part of the equation. It's okay, I don't know why. Sometimes it gets bugged. And we can do the exact same thing for the L-infinite. Paste it. And here, instead of L1 limprop, we call L limprop. So we can call this solution 1 and solution 1.
They have the same name.
No, 2.
No, it's no.
Pero ahora cuando pones el
a block for N1 and you do a block for NE, then it's almost the same. It's the same, you can call it beta, beta. You can call it beta 1 if you want.
No, we should first define crec que la matriu, el once no em munta una matriu. A mi no me la munta, li he fet un print i no em munta una matriu. Em munta una... O sigui, l'XTR em dona una... deu ser una 10x2, però l'altra, el once, només em munta...
Aquí dius els auxiliars aquests.
Sí.
Perquè crec que aquí sí hem de fer vector, això. Ok, sorry, so... I think this is...
Yeah, instead of beta I1 like I did.
Estava bé.
Sí?
Dius que això no t'ho fa el que dius.
Doncs mira, li he fet dos pins bàsicament i me'ls munta diferents. No, bueno, li he fet a un altre lloc, però sí, va, fes-li abans, perquè si no et salta l'error primer. Això dic.
Then beta. Theta, sorry. Theta, perfect.
No, sobre un parèntesi.
Sobre la coma, potser.
Perfect. Check the name.
I falta un parèntesi.
Okay, and now you copy paste this. Okay, now you copy paste.
Sí que fa el que tu dius, sí que fa la matriu, no? L'opció? Que sí que fa...
Fa bé.
Ja sé que second time is the same. And then, instead of storing the solution in beta theta L1, you store the solution in theta L2. Perfect. And try to write it back. Let me see.
Crec que li has de ficar shape sense el 0. És a dir, com que és una matriu...
Llavors te torna un vector a la shape.
Clar, torna un vector de 2 punts, que és el que li estàs dient del tamany. Ha de tindre el mateix tamany que la matriu A.
No, perquè you are saying in here, when you say once, you have this... This is first you say you want rows equal to rows of A, and then in the second direction you want just 1 point.
You want one vector.
Yes.
You need a matrix. The error that is giving you is that you need a matrix. The error that was giving you, I think,
because this one I copied from the solution. This one on the bottom and it works. I don't see any difference. This and this is the same, but this I copied from the solution that I did a few days ago, but I don't see any difference.
Yeah, there's one more parenthesis.
Where? Go a little right, not 2 parentheses, but 3.
You're missing one parenthesis.
No. Okay, we are missing here.
Yes, someone said it in the chat.
But you need a vector. You don't need a matrix.
You need a vector of ones.
Of ones. Okay, it's not a matrix. It's a vector. Okay.
And infinity norm.
Here.
So they try to actually find the maximum.
Parenthesis is not here.
So they try that in average, it's the same everywhere.
Here was one parenthesis that it didn't go there. It goes more to the.
Generally,
So it was generating a vector, but we need a matrix. Oh, now it works. Okay, so yeah, the error was here of this parenthesis that it was put it here, but here. Okay. Are you have you solved this? And you can run this one on the bottom. Someone needs help. Any questions?
Can you wait?
Yeah, this. Okay. Okay, so
you already saw it. Okay.
In Sol1, we have it's a data structure because it returns, apart from the optimum parameters, it also returns a message about the minimization, if it went well or not. So we are gonna save in another variable just the sol1.x, which means the parameters. We want the parameters. We don't need anything about the message or some other thing that it returns. And as well, as we were minimizing x and t. So he's returning in the same vector the solutions for x and the solutions for t. But we just want the solutions for the parameters x. So here we are going to just cut to the we're going to go from 0 to the same shape that theta has. We can put this and the same for the L infinite norm. We just want the solution x, and we just want the same shape as theta. So now we can run the cell below, which will show the solution. It's working. You have the same plot on the right and the left.
You found an error in the last line. It says sol1 and it should say up the other side.
Yes, thank you. Sol2 here. Yeah. Now we have the solutions. You have this, or anybody is behind? Who is seeing this plot now? Okay, so do you see the difference between L1 and L infinite? Like Alex was explaining, L1 just doesn't care about this outlier because it's trying to minimize much more the lower values. So it fits a line perfectly through all the other points, but it just doesn't matter. This one doesn't matter to it. Whereas the L infinite norm is trying to minimize the maximum value. So it just takes the middle line that has the same distance up to this point than to all of these points. So 4 again.
No, no es que no salga un error. Es que no.
So here we can see that sometimes choosing another norm instead of the typical mean squared error problem choosing L2, we can choose L1 and we have a much more solid boundary, so we get a better predictor because we think this point is an outlier, and now if we are trying to predict a new point that maybe is here, it will go through the exact line. Instead, in the L2 here, a point from, if they give us this point, we would have predicted right here the slope. Okay, so questions from the chat? Any questions about this first part, about the L1 and L infinite norms?
Open the two frames. No. Yeah, you have some error over there.
L1 but it was yeah. Why did you change it? Something? Function? Did you change something? No, you didn't have to change it in this one.
Vale, o sea, no
Yeah, there's one
that
should be yes, I'll pick up.
o sea, está curioso.
One and two.
This one, comma one,
Perdón, pensaba que era una más igual.
New? Yeah, here is okay. So run this.
Pensava que volies una matriu i no t'està dient això.
Here it's not L. No, because it's not this function. It's from the library of. This is the solver. We set up the but this is the solver. It's Lindbrock in lowercase l. Yes. And now here, you have to go here as well. Here you have to go line number L1, file property, and the what you L block. Yes. Line numbers, sí, pero yo tengo.
No, perquè el teu és un...
Vale, perquè l'he posat al company no.
Perquè captura.
Ja.
Más adelante.
Okay, so this is it for the L1 and L infinite norms, and now we will move to regularization. Okay, this is the last thing that we saw this morning. So to see regularization, I'm going to explain a little bit something more about machine learning. But we will use the other data set, which is the cubic. So you can just run this cell, which calls it. and we can see the data here. So here we just called two more methods, scale and split data, that I didn't explain. But basically what they do is scale, it moves all the data to a 0-1 interval. So we had this data that in X, for example, goes from -1 to 3 and in Y to 1 to 8. So when we scale it, that the data is in 0-1, 0-1. This is usually done in machine learning because in neural networks it's really important, and it's always done so that you have closer to the origin the data. And the other method is the split data that Alex explained also, that in machine learning we want to divide the data in train and test. So we can train the model and then test the performance and decide if we like it or we want to change some parameters, like the lambda or the polynomial degree, for example. So we have here a polynomial degree of data which resembles a cubic equation with a little bit of noise. And using the analytical L2 solution, we can find the regression lines that we want with different polynomial degrees. So just like we called the solution for here, to find this, it's like this. We can do the same to find the solution for this data set with different degrees of polynomial degrees. So you can also try to write this. You have a few minutes, I will help you as well, and then I show you how to do it.
Es como lo que te ves. Que te ves a ti mismo.
No, es lo mismo.
Sí, sí. But no, that's just to represent something related to first one here, for example.
You should do same, in this case.
The first one here. On one because well yes, yeah.
Una pregunta, los datos quieres que estigma en segundo.
Las columnas y tags.
You already have the nice, because we're going to do 3 plots.
Potser afegir un show canvia tot
No, perquè el suport és una funció si no passa nada. I si no va mal.
No, pero claro, yo tengo como varias estas que no sé si llaman como 3-2 o 3-3. Ya pasas
Cómodamente.
Sí.
I'm not using the same data.
Ah, right, you're not using L1.
We're using Qt instead of data one.
We're using esto guardado en un principio.
guardar.
Pues como esta validad solía estar en try.
I made it much helper.
Okay.
Esto no sé dónde salió. En algún momento lo hemos
So I copy.
So, but now instead of using cubic and instead of x,
Pero no sé si sale de algún sitio.
no, hold on. I've said that instead of x cubic dot x, we are using cubic x train because we will do some training. You can change the
Yeah.
and we don't have to use that one link proc. We're doing the L2. Okay, so we coded analytic L2. I don't know if you remember. Using these two lines. The analytical 2 directly returns the parameters.
Okay.
So you just say theta. Analytic.
And
Then take this away. Parentheses. X and
Exactly. And here you tell him you want.
that's for all, right?
Yeah.
Three columns of plots. And here, this is gonna be the first one. Exactly. If you do 3-1, you have a column. Try to put exactly.
Yeah, I think I changed them because I tried different, but they are pretty similar. It doesn't really matter.
3x3 matrix. Expecting for here. And change this 3 to 1.
String.
Okay, so we have to call the two functions that we did at the beginning, which are build model and the analytic solution, because we are doing L2 regression. But now we have to do it with the cubic data and with the train set. You just write cubic.extrain and these two lines. And just like before, we can just use plot solution. So we plot and find the solution.
It's going to stay empty because
Yes. So you should have something similar to this. First build model with cubic now, extrain, and then the analytical solution, and we plot it, plot solution.
That's it. Because everywhere it's instead of just x, it's an except for you're yeah, perfect. And run this. Yeah. Yes. It doesn't change pretty much, but now you're training on this data.
So when you run it, you should see these 3 plots. Being able to.
Who has these 3 plots already working?
Okay. So we can see the 3 cases when we just give the model too few capacity and straight line clearly doesn't represent this data. Then we used a cubic, which is similar to data. And finally with 10 degrees. Let's see. And finally, with degree chain, we can see that it can do and fit better the blue points if it passes through them. But at the cost, for example, of here turning upwards, which will be really bad for these red points. So this is what we call overfitting. And we have to, we try to avoid it by introducing the regularization term that we explained before. So what we can just do is do the exact same that we did, but to the analytical 2 formula, we can rewrite it now so that we add the lambda E term. So before we didn't have this. So if we add this to the solution, we will penalize overfitting. So just to write this equation here, you have a few minutes. It's similar to before, but now with the term lambda.
You think it's random or it's always the same?
Y aquí no sé, a ver si lo podemos hacer aquí.
So it's compared.
Yeah, we are running out of time. Yeah, but we use
it doesn't matter too much.
We use iterative methods. We will have many.
So the more to plus, you can do it.
So this will
It doesn't matter. Now then you plot the data first. And then the solution. Try it.
We don't want to sort it very well.
Now formulate. Training and testing data is not exactly the same in your computer and in your computer.
Sí, cada una se tiene diferente porque está pendiente de
Also be random.
Entonces, yo creo que esa forma
Like if you look at the points, for me it's only it's not maybe we compare this.
Por eso.
Okay, wait 1 second. Because we should already see here, right?
That's because the line that you're producing is 1 degree, yes. Polynomial. Yeah, and then the second one is 2 degrees. Well, it's 3. 2 turn, and the other one is 10. And
Subplot command, right?
sorry?
Using subplot command.
Yeah, it doesn't matter.
But you have to do it again for D3, D equal. Put it in both only. It's the size of the figure. Yeah. That was saying.
You remember in the PDF, there was this whole exercise. Now you just have to go get this whole formula or this exercise. So it's almost the same as before.
¿Pero por qué? I don't know, it kept taking error. No, porque es fixed size.
Regularization, sorry. It's the same as before.
The error is input equivalent to 0 does not have enough dimension.
No, porque no has hecho el billboard. O sea, esta fila no es del cada vez que le cambies la tele tienes que volver a hacer el billboard.
Yeah. You don't have to.
Si un copia este, el beta, XTR. No, andamos esta de aquí.
Yeah, exactly.
No, debajo del 10.
I think so.
Yeah,
That's what I want.
pero lo que pero cuando pone una línea es que lo estaba tomando como cero, o es que no lo estaba.
No, te lo está graficando, pero la salida es
What?
We don't want to edit. Can I write like for equals 1 to 3?
Yeah.
Then you can
You want to put it on the
con regularización la de
what you might, for instance, do implicit say 1 because
mejoró la última nada más. O sea, la primera está igual.
Yeah, you can set here, instance here you can put
La última.
1, 5, 7, 9, 12. I don't know if it's enough. It's less than 10. And then here.
Maybe summation.
Yeah, it's the problem with
Here, what you also have to do is put in this D, this number. Here you have a lot of.
o sea, si es el que llevo,
pero es igual, seguro. Sí, tú no sabes lo que
Yeah, but it is. Yeah, but it's not 12, yeah. I don't have 12. That was the same. That is 3 from 3.
Perquè verifica el vermell encara.
1, 2, 2 or 3 by 3. I had this problem.
Estic donant aquí amb el... Perfecte.
Let's remove one parenthesis here.
Para estos layers
Maybe this is
Or f.shape, but instead of the include product.
I don't know why it's not maybe because you have this one. But yeah, maybe that you can do it visually. Or also you can
It works. I'm going to put it horizontally. To put it horizontally.
Sorry.
If I want to put it horizontally.
Yeah, I think it's working. I don't know why running. I should do a 3 by 3, but I don't know why this thing is not getting.
I put out just one.
No, well, yeah, but you then do a while and this is iterating.
Because it's supposed to
Cannot see. Yeah.
Pero pues no ningún audio.
Sí, eso es audio.
Yeah, it's allowed. Yeah, but it might grow, but yes.
in this addition, the sides are wrong. So it says on the left.
Sí, puedes ir copiando y pegando.
No, espera, aquí va.
Bàsicament, sí, l'únic que has de canviar és analític, canviar això d'aquí per analític regularizer i posar-li en 0,0.
Si algo menos.
Está mal. A ver, obri el...
Intentant entendre perquè m'ho fan de perfecció operativa.
Sí, amb la d'igual a 1 sí que em podria... És el influence pack.
Mira.
It's the same one as
Entonces, a lo mejor cada vegada te está cambiando només la primera columna. Has de ficar I. Entonces, a cada iteració del for te farà una columna.
Ara aquí puc posar 0.
Igual. Sí, pot ser això abans. Però da igual, sí. Està bé.
I ara puc córrer l'altre.
This shape is not correct one.
Perquè al multiplicar l'altra posada per l'original.
Clar, perquè et dona un vector. Perquè l'original
ensenyem això i...
no, perquè són el mateix tamañ. No, està de donar una matriu.
One number that says the right size.
So you have to write this, which is just here to that equation that we had before, add the identity times lambda, run it, and we can do this same plot before with d equals 10, changing now the value of lambda to see what happens. So we just copy because we are running out of time. So it's the same as before with the build model, and if we use analytical 2, which is the one that we used before, we have this plot. But if we introduce lambda, which the values usually are really small, then try this one. we will see how it regularizes the function. So this was before, and now with lambda 0.0.1, 0.001, we have this, which has regularized the function. So if we start in increasing lambda, for example, 0 less, what will happen? It will happen that this function, it's even more smooth, so it will start to fall apart from the solution. See, it's moving up this, keep increasing lambda. Getting now, it is a parabola. It's far away from optimum. So we have to find the lambda that best suits the model. If we put lambda 0, we have this thing that it was overfitting, but if we take too much lambda, we will be penalizing too much the parameters and we won't get a proper solution. So usually what we do is we do this what we're doing here, find the solution and take the we calculate the error with the test set, and we do that for different lambdas, so we can find the best lambda, the one that best suits our model. I don't know, you can write.
So just to see it again, with lambda equal to 0, it's in the left hand side, lambda equal to 0.001 is in the right hand side. So for example, this is a good fitting, but if we start increasing lambda, can you do it again, please?
Yes.
1, for example, or like this 0.01, you start seeing that we are having less accuracy, more smooth, but less accuracy. And then if you will do 1, it's too regularized. So you have almost not linear, but a parabola. So you are losing like that, the capacity once you add too much lambda. So lambda plays the same role as the capacity. And the good thing is that with lambda, you can have very large capacity and you can adapt to at each point what you need. But at the same time, you can control how much the capacity you need, so you will not overfit. So it's better to use lambda than using the dimension.
Yes. So you usually set a big dimension. You take a big polynomial degree, and you find the lambda that regularizes your problem instead of trying different polynomial degrees. So we will just see it from the solution because it's already 4:30. So we can go to the solution and run it. I think you also have the solution uploaded. So
like everything you wrote.
Okay. So as I was saying, as I said before, what we usually do is we take a variety of lambdas here. We make a vector 0, 10 to the -8, -7, keep increasing it, and we do a loop iteration to try all the different ones, and we usually plot it like this. So we get error in the y direction, and in the x we get the value of lambda. So we can see which is the optimum lambda. Also, this is plotted for different test train ratios. So with higher test ratios, we have less data for the training, so it overfits easier. So we will need more lambda, and it will be more important. So as we can see here, we have the training. So introducing lambda to the training, it's bad because we are just adding a term that we don't like. We will fit worse the train. So the error will start increasing no matter what as we increase lambda. But for the test, as we can see, especially for the 60% case, which is the one that will overfit the most, the lambda will start to decrease the error, eventually reaching an optimum, which for 60% is this one, but for the other two, it's a little bit more to the right. And then when we have reached the fitting case, we will start to lose even more capacity and get worse solutions. So we do these plots so we can find the optimum lambda, and we can do the same, but instead for different percentage test ratios, we can do it for different polynomial degrees. So we can see that with high degree, lambda is really important because we are overfitting and we will need to introduce lambda so we can regularize the model. But with d equal to 3, lambda is not doing anything because d equal 3, it was already what the data was. So lambda does nothing and eventually starts increasing the error. And if you have any questions, I think we will end this session here. So do you have any questions? We see that lambda is important. It really helps to reduce the test error to prevent overfitting.
Okay, so yes, question.
If you have the complete data, how do you define which part of the data will be training and which part will be?
It has to be random.
Random.
It's random, yeah. So every time you train, you can get different results, slightly different results, but it's non-random, so you don't have any bias on the data.
Yes. You can split it, for example, in 5 different. So the first 20%, then the second 20%, and you do it for 5 examples, and then you take the mean and the standard deviation, and you see how the error is with lambda also, but the mean value and the standard deviation. So typically what you do is you split the data in 5, for example, parts, and you solve five times the problem.
That's cross validation.
And this is called cross validation, this procedure. People usually use it for in regression. Okay, so for tomorrow we will have constraint optimization in the morning. Then we will have logistic regression. So we will do classification tomorrow in the machine learning, the theoretical part also, and we will do it in the practical part. I think we will do this again a little, just to for the last part that was a little fast. We can do it again, and then we will do a classification example here also, like this one. And of course, if you have questions, you can ask me, and also to Tony. So thanks, and see you tomorrow.
Recording stopped.